Hello scientists, we're here to finish up part 2 of the Levers Lab in Unit 6. So let's start by reviewing the lab sheet that we were finishing up on the last part of the lab video. We had looked at the resistance arm, that's the end of the lever where the resistance or the mass is. We multiplied the force times the distance to get the work going on the resistance side. We measured, this lever was balanced, so we didn't have to measure just the mass of the lever itself or the force of the lever arm. We just measured it with the mass on it. We multiplied the force times the arm length and we got the work on the effort side of the lever. That's the side that we pulled on with the spring scale, remember? So we can see that the resistance and the effort side are doing about the same amount of work. It should ideally be exactly the same as we saw in that simulation earlier in the other part of the video, but unfortunately nothing is perfect in the lab, so these two are just slightly different. Now when we use the 300 gram mass and we reduce the arm length to 0.2 meters or 20 centimeters, when we multiply the force times the distance, this is the work we get. And ideally, we should be doing the same amount of work on this side. But this time, since the lever is not balanced in itself, we're going to have to measure the force applied to the balance with no resistance on, no mass, which I forgot to do at the end of the first part of the video, and then measure the total force with the mass on the balance. Subtract those two to get the total force and multiply those to get the work. So let's go to the lab and see how this all works out. Remember, in the first part of the video, we used these arrows to change where the fulcrum was on the lever. We wanted the resistance side to be 20 centimeters, so we put it at 40, and the difference between 40 centimeters and 60 centimeters is 20 centimeters. So the resistance arm here is 20 centimeters or 0.2 meters. And then we're adding 40 centimeters here to 60 centimeters here. 40 plus 60 is 100 centimeters, or the distance between the fulcrum and the effort here is 1 meter. Now let's measure the force needed to just balance the lever. We're basically looking at how much gravity is just pulling on the lever itself. How much force do we need to just get it to be level? And that's 1.70. So we're going to go record that in our data table, 1.70. So right here, we just measured the force applied to balance the lever with no mass on the resistance side. So this is 1.70 newtons. Now we're going to go put the mass on and get this measurement. So remember, we want to use 300 meters, so let's go over here and pick up 300 meters, or 300 grams, excuse me. We have 300 grams. Let's zoom in to make sure that we actually do have 300 grams here. There it is, 300 grams. All right, I can zoom back out. Now, let's measure the resistance here with the mass on. Oops. I have to put the mass back where it belongs. Notice I center the mass on the 60 centimeter line. Let's just get it level here. 1.24. 1.24 newtons. So now we want to find the total force just to lift the 300 grams. So I'm going to use my calculator here to subtract 1.70 from 1.24, and that's going to give us a negative number, but it's okay. 1.24 minus 1.70 just means the force is in the opposite direction. I get 0.46. When I multiply that times 1, because the arm length on the effort side is 1, I get 0.46. And 0.46 is not quite equal to 0.59 here. I'll change them both to green so it's easier to see. But this is in the lab, and nothing in the lab's quite perfect. But you can see that the work done on both sides is almost equal. Now let's go do this one. I'll set this up and you can do the calculations. So for this last part of the lab, we're going to set the lever up differently. Let's take off the balance here, or the spring scale. And we're going to set things, we're going to move the fulcrum to the opposite end here. So now that the effort arm is 20 centimeters, the end we're going to pull on is going to be 20 centimeters, and the resistance arm is going to be a whole meter. Let's take this mass off here so we can measure just the force. Remember, we're just going to measure the force it takes to balance things to begin with no mass on there. Here, we'll center it there. And I got to pull carefully. We're not using much distance, so we're going to need more force here. I'm going to need to pull with about, well, about 15.81 newtons. And that's with no mass on it. 15.81 newtons. Here, I'll let go. So here we are back on the lab sheet. This is 15.81 newtons. Now notice that I had set up the arm length for the resistance end at 1 meter and the arm length on the effort end as 0.2 meters or 20 centimeters. So I have to pull with a lot more effort because the distance I'm using is a lot less. Remember, simple machines usually reduce the effort by increasing the distance. But here, we've decreased the distance, so we have to increase the effort. And you can see that in the huge difference between the amount of effort here, where we have a really big arm length, and the amount of effort here, where we have a really small arm length. Now that we're done measuring it without mass, we can put the mass here, and now we can measure the amount of effort it takes with the mass on. And remember, we're pulling over a very short distance here. Whoa, it's a little bit harder than it looks. Here, let me reset the mass and pull very gently and slowly. Looks about 24.87. Well, get it level. Let's call it 25.8, 25.9. It's hard to hold it level. 25.9. Okay, so we measured 25.9 newtons here. And remember, we need to subtract A from B to get this measurement, and then we need to calculate work. We need to multiply the total force times the arm length to get this number here, which should kind of approximately match this number here. I'll let you look at the rest of them, the lab questions here. Make sure you don't forget to answer question 11, 12, 13, 14, and 15. In order to do the pulleys lab, that will be a different video. Thanks for watching. Here's a picture of me moving some force across some distance and doing some work. We'll see you in the next video on pulleys.